In this video you'll get an overview of how you can simulate energy loads using Vasari or the conceptual environment within Revit, and quickly creating energy models that you can pull into Ecotect Analysis for doing more detailed simulations, changing your material properties, orientations, etc. So I've now opened Vasari, or it could be the conceptual environment within Revit. And what I'm using Revit and Vasari for is really creating energy models with pre-dimensioning glazing that I can quickly pull into Ecotect, where I can do more detailed analysis, changing the exact properties of walls, windows, ceilings, roofs, etc. I also have the ability to look at the results and compare by doing analysis in the cloud, but because it's really North American standard, it's really not that transparent where the heating and cooling loads come from or how big they are. But this can give us a very baseline understanding on where do we have the largest impact of cooling loads, where do we have the largest impact of heating loads. And we can of course just mark more than one here and compare them visually, or we can just mark them out and take them into Excel to kind of be able to monitorize our design development. So whether we are working with a very conceptual form, we can do analysis within the conceptual energy analysis in Vasari and Revit, exporting it out as mass model GPXML, or we build up a more detailed model that we're exporting to Ecotect using the GPXML, using the interior print of the rooms. We can effectively take this into Ecotect Analysis and do pretty validated simulations of our design. So Ecotect is really kind of a pretty comprehensive analysis tool. So when we pull the model in here, of course we need to make sure that the model geometry are functioning in the right way, and that means that the directional arrow should always point from the inside to the outside, and the relation that we can check out here in the selection information between the parent and the child object should always be calculated correct. So to make sure that these links are really set together the right way, click Fix Links and mark the two ones below here and say OK. So now the model is ready to do thermal analysis within Ecotect. So let's go to the Analysis tab. And the first thing I'll look at is the heating and cooling loads in here. So you see that because I, in user preferences, set it to be kilowatt per hour, I now get a number here that I can put out in a report to compare in Excel, or just using it in here. Other way I can do is to say store results, and I'm now able to go to select by element type walls and go to the materials and just right click the materials and change, for example, okay, I want to change the U values for 0.14, apply changes, close, and then I can recalculate my design. So you see this really didn't make the largest impact. So, but what I can see here is that I have some cooling needs during the summer and some heating needs during the winter. So what I'll do next is that I will try to identify where does these loads come from. And to do this, I'll go to Passive Gains Breakdown, which is a very cool graph that can show me the relations of the different loads within my project. So what I can see here is that above the line, this is where my gains are, and below, this is where my losses are. So you'll see that because of the very good U values of materials, I really reduced the amount of conductivity to materials, but I have a lot of gains here during the summer because of direct solar. So what I could do now is that I could go in and say, okay, this is something that I'll go in and I'll look at my windows, select my windows, and to look at properties and say, okay, 0.7, I want to change this to be an energy window here, say okay, and then recalculate to see the effect. So now you'll see that I really had some value of doing this, and I can go back to my monthly load discomfort. I can say store results, and I can recalculate to see the impact of the changes that I did to my material. So changing the material is one thing. You see that this was quite helpful. I'm now down to reduce my cooling loads a lot. So the next thing I could do is go into my model to begin to work with solar shading, begin to work with the orientation of my building. So you see that just changing materials or working with orientation is very fast because you don't change any geometry. But as soon as you're changing geometry, you need to recalculate the shading condition from inside the model, and that's when EcoTech kind of triple the time that you'll spend doing these simulations. But really effective to work with this program, and in the next video I'll go more into details with this.